How you doing guys, Bioinformatics guy here with the third video of the series Python for Bioinformatics. Before we start the video, I have an announcement for you. And I know it's been quite a while since I uploaded the last video, so I am back with the good news for you. The good news is now we have our own website, bioinformaticsguy.com. I will talk about the details of this website at the end of this video, so let's start our video. In this video, we will be talking about expressions. Expression includes numerical operators, string operations, and logical operations. So the combination of operators and operands is known as expression. Now let me explain with a few examples what are operators and what are operands. So you know how the proteins are made in the cell. The ribosomes get the messenger RNA and then they convert them into the protein. Moreover, let's take another example from the real life. So whenever you go to buy a ticket from an airport, you give your passport and you give some money to the agent behind the window, and then that agent returns you the ticket as well as your passport. In these two scenarios, we have a few things on which some process is done, and there is one thing which does the process. In the case of protein make, the ribosomes are the operators and the proteins and the mRNA sequence are the operands. Similarly, in the case of buying a ticket, you know that the agent is the operator and the ticket and the money and your passport are the operands. So these are the general examples of expressions, operators and operands. So let's start exploring what are these things in Python. Before we start, let me tell you, previously we were running our Python scripts in Python IDLE, but now I am using Linux, and in Linux there is another way to run Python code, and that is by using terminal. You just have to open the terminal, you have your terminal over here, and then you have to type here Python. Okay, if you are unable to get Python after typing Python over here, Python is not installed. You just have to install Python in your Linux machine. So first on the list is numeric operators. In your elementary school, you must be familiar with these signs: plus, minus, division, and multiplication. So you can see that the plus sign is the normal plus sign. You will be also familiar with this minus sign. You will also be familiar with this division sign, but this star is quite unique over here. You like to use this cross for multiplication, then this star, this cross. So these are numeric operators that are used in Python. So they basically do the same thing. The plus adds things, the subtraction subtracts things, multiplication sign, which is star over here, just multiply things, and the divisions just divide things. So let's see a few examples how these things work. Let's talk about the addition. 2 plus 3 is equals to 5. The subtraction will go simply like 2, 3 minus 1, and multiplication will go like 2 into 3 is 6, and the division. So before we talk about division, which has quite a few options, let's talk about how you can take power in Python, like 2 raised to the power 4. So in Python you will have to use two star signs. 2 raised to the power 3, you will get 8. So let's talk about division. So you know that the whole operation of division has quite a few things. There is a quotient, there is a remainder, and sometimes you will need the quotient, and sometimes you will be looking for the remainder when you perform a division process. So in order to get the full quotient, you will have to use this single slash sign. Like 12 divided by 4 is 3, 11 divided by 4 is 2. Now you know that 11 is unable to be completely divided by 4, but we are getting 2 over here. It means that this is not the complete result. Now sometimes you will see some discrepancies, like in terminal this gives us the different results. So let's try this in our Google Colab. So this is my Google Colab sheet, and let's try running this over here. 11 divided by 4, and you get 2.75. Now this is the complete quotient. I would suggest that whenever you are coding, whenever you are writing a program in Python, you should use it interactively. Just open a shell, which could be idle or which could be terminal. Keep on checking your code before entering it into your whole main script. In this way you will get to know what are the basic things that might be different in different platforms. So now you know that over here we are getting 2.75, but over there in terminal we just get 2. Now let me tell you how you can get 2.75 over here. So over here, if we divide by 4.0, 4.0 being a float, you will get the full result. Alright, so that's how you will get the full quotient. Let's talk about if you want to get just the thing before the decimal point. In order to do that, you will have to do 11/4 and you will get 2 again. Now, if you will do this in Google Colab, you will get the same results, 11/4, and you will get 2. Alright, wait, I must stop you here. I am here to tell you something very important. The discrepancies that you have seen a few moments ago made me really curious to find out what is the exact reason behind this whole thing. So I have found out that in Linux, whenever you will type Python, it will load Python 2, and you can see over here that this is Python 2.7.17. In Python 2.7.17, whenever you will write something like this, 11/4, you will not get the full quotient. However, if you will run the same thing in Python 3, you will get the whole quotient. Let's try Python 3. Now we are in Python 3.6.9, and let's try the same thing again, 11/4. So we got the full quotient. Now the thing is, in Google Colab you were able to get the full quotient because Google Colab supports Python 3 by default. So whenever you are running Python scripts, make sure that you are using the correct version of Python. If you are working with a script which is in Python 2, you need to be running it in Python 2. If you are using Python 3, you need to be running that script in Python 3. Now the thing is, most of the time Python 3 is used nowadays, so you don't have to worry about that. But whenever you are working in a Ubuntu or in Linux machine, Python 2 and Python 3 is already installed, and most of the times when you will just type Python, you will get Python 2. So you need to keep an eye that you are working in Python 3. Now there is one more thing that you can learn from this, is that we have completed this whole video in Python 2. So there are very minute difference between Python 2 and Python 3, but still those minute differences can sum up and cause huge errors. So it is a must to keep an eye on the version of Python that you are using. So what if you want to get a remainder? In order to get the remainder from the division operation, you will have to use this sign. Now you might be saying that this is a percentage sign, but in Python this sign is known as modulo. So let's start by 11%11. You should be able to get 0 because it's completely divides. Let's try 11%4 and you get the 3 remainder. So that's all about division. Now there is one more thing. In Python, if one of the number is float, the whole answer turns out to be float. It happens because Python converts the rest of the things into floats if you have one float in the whole expression. So 2 plus 3.0 will be 5.0 rather than being 5 only. So 5.0 is a float, and if you get a simple 5, it's an integer. So you can try this with the other operators like multiplication and division. Let's try it with multiplication. 3 into 4.0 is 12.0. So next on the list is logical operators. These are Boolean, and, or, and not. So and is when both of the values are true, you will get true. Or is when either of the value is true, you will get true. And not is just the reverse of the value. So if you have true, not true will be false. If you have false, not false will be true. It might look like that you will never need to use these things in Python. Later on you will see how these are used, and I want you to have an idea about logical operators. So if we write true and false, we are supposed to get false. And if we write true or false, we will get true. And if we get not true, we will get false. If we write not false, we will get wrong spellings, we will get true. Oh, wrong spellings again. Not is supposed to be small, right? So you can try a few more combinations on your own. Let's talk about the thing which you will be using most in the whole series. So these are comparison operators. So next on the list is comparison operators. You will be using them a lot in this whole series, and there are quite a few different types of these operators. So let's start by the most easy and simplest one, which is equals to. When you want to see that two values are equal in Python, you use this equal to operator. Now in your real life you will be familiar with this simple single equals to sign, but in Python you will have to use two sign. The single equal to sign is used in Python for something else, so that's why whenever we have to compare two things we will be using two equal to sign. Now you can see that 2 equals 3 you will get false, and 2 equal 2 you will get true. So next on the list is not equal to sign. Whenever you want to see two values are not equal, you use this sign. So you just have to throw an exclamation mark before an equal sign. So this is your not equal to sign. So 2 is not equals to 3, you will get true, and 2 is not equals to 2, you will get false. Next is less than sign. So 2 is less than 3, true, 3 is less than 2, false. And you can also add an equals to sign if you want to see whether it is less than or equals to. So 2 is less than or equals to 2, you will get true. And same is the case with the greater than sign. This is the greater than sign, you can try on your own. 2 greater than 1, true. 2 greater than 4, false. So next is the most important thing on this list, which are the string operations. You already know why strings are most important in this series, so that's why the string operations are also very important for this whole series. So we have learned some binary operators, and 4 of the binary operators can work with strings. So the first one is the addition, the second one is multiplication, third one is in, fourth one is not in. Let's talk about the addition thing. So if you have the string ATGC and you want to add another string GCGC, you can simply add them just like that. And you can also multiply ATGC into 4. You will get 4 ATGCs. So these are the basic ones. The next is in. In is going to be very useful. This is used when you want to see whether a small substring is in the bigger whole string. When you want to see that the small 3 to 4 base sequence is in the whole gene or in the whole genome, you can use this in operation. Like we can see that AT in GC A TC GG A, and let's throw another AT over here and you will get true. If you will change this to TT, since you know that there is no TT in our sequence, you will get false. Not in is just the opposite of this operation. CAT not in, you will see that you get false. And let's try this same with the TT not in, you are supposed to get true. So in string operations, the next thing is subscription. When you want to get a single character from a string, you will use subscription. So let's see that we have this string ATCGA and we want to get the first element of the string. So in order to get the first element, you will write this square bracket, then enter 0 over here, which is the index of the first element, and then you will get A. If you want to get the second element, you will type 1 over here, so on and so forth. And if you want to get the last element and you don't know what is the length of the whole string, you can use the -1 sign. If I will type -1 over here, you will get the A, and you should know that this is the last A. And if you want to get the second last element, you can use -2. So the positive indexes starts from 0 and the negative indexes starts from -1. So the next on the list is slicing. Whenever you wake up in the morning and you want to have breakfast, you have the bread. The thing is, you cannot eat the whole bread. You use the slices. Same is the case with slicing in Python. So you will have a whole millions of base pairs of DNA. If you want a little chunk of the DNA, you can use this technique, slicing in Python. So I have this protein sequence. So getting a slice in Python is very similar to the subscription. You just have to use the square brackets. You will enter your starting point. We will start from 0. Then you will have to add a colon. This will make Python know that from over here, the ending point is going to be mentioned. So let's keep the ending point 3 and see how many characters we get. So we got M and K. You can see that we got the first 3 characters, but you know that if the index starts from 0, it is 0, 1, 2, 3, like 4 characters. We were supposed to get 4 characters. You need to know that in Python, the ending element in the index will not be included in the slice. If you want to get the first 4 characters, you will have to type down 0 to 4 over here. In that case, it will count from 0, 1, 2 and 3. The fourth element D is not going to be included. Now the slices can also be negative. So in that case, it will start from the very beginning and it will end at -4, which is going to be -1, -2, -3, -4. Now there is an interesting thing. What will happen if both of the indexes are same, like 5 colon 5? And what will happen if the indexes are in wrong order, 5 column 1? Right? I'm not gonna try this out. You have to try this on your own and then just let me know what are the results in the comments down below. Now there's an interesting thing in Python. You can omit the number if your slice includes beginning or end. If your slice includes end, you will include the number at the right side. So you will get the whole slice till A. So if your slice starts from beginning and ends somewhere, then you will omit the first number. Interestingly, in Python, you can omit both of the indexes. Pause the video, try it out and let me know in the comments down below. So far, we are working with the 2 elements in a Python slice. Interestingly, there is a third element in Python slices. I will be explaining this third element with another example. 80, 80, 80, 80, 80, 80, 80, 80, 80, 80. Okay, I have this sequence now. So the third element in the Python slice is the step. This indicates the number of elements that are needed to be skipped after each element that is included. If we start from the very beginning, which will be 0, and go till the 6th element, and we want to skip every second element, we will write it this way. Now you can see that we only got the A's, and if we start from the second element, then you will get all the T's. Now steps can also be negative. When the step is negative, the Python takes the strings in the reverse order. So if the step is -1, you will get the reverse of a string. Oh, we got an empty string. You need to know that if you are giving the step in negative, first index should be greater than the second index. So now you got the string from this S till this N. If you want to get the string till this M, just omit the starting point. Okay, you got the M. In Python, if you want to get the whole string in reverse order, you will start from the end, you will end at the very beginning, and you will go in the negative order. You will get the whole string in reverse order. I would suggest you to play around, try different expressions and string operations and see what are the results you are getting. So that ends the expressions topic, but you can use these expressions in combination and make compound expressions. So let's try this. 2 into 3 plus 4 minus 1. You will get 9. So let me show you how things are done in this. 2 into 3, which is 6. 6 plus 4, which is 10. 10 minus 1, so you get the 9 answer. This was quite simple. Let's try this. 4 plus 2 into 3 minus 1. 4 plus 2 into 3 minus 1. What should be the answer? Let's check it out. You got 9. But according to our previous thing, we will see that the answer is supposed to be 4 plus 2, which is 6. 6 into 3, which is 18. 18 minus 1. So our answer is supposed to be 17, but we are getting 9 over here. Now the thing is, just like in high school, you might have came across this mnemonic DMAS, D-M-A-S. So on the top there is D for division. So division has the most precedence. It will be performed first. Then there is M, multiplication. Then there is A for addition and S for subtraction. So Python follows the same rules. However, if you want to get specific results and if you want to specify how to calculate these things, you can put them in the brackets. If you want to get the 17 answer from this whole expression, Now we have specified that first of all you will have to add these 4 plus 2. Since multiplication has the most precedence, it will multiply it by 3 and at the end it will subtract. Now you will get the same result 17 from this expression. Comparisons can also be combined in the form of between expressions. 1 less than 4 less than 6, you will get true, and you can go for 2 less than or equals to 2 less than 5, you will get true, and 2 is less than 2 is less than 5, you will get false. Now strings can also participate in sequences of operations. So we have this string tc. We want to see that if this string is in this whole thing. Let's add a t plus gc 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 plus, let's throw a tc over here, and then ta. You will get true. If you will change it to tt, you will get false. So that's all about operations. If you want to dig down deeper for more information, you can always Google like this: Python operators. I prefer this website W3 Schools. It contains a lot of details. So these are all the Python operators. We have already talked about this. You can go into try this. It will also get you a lot of examples. You can run Python code over here, and this is another way to run Python code. So before we conclude this video, I have a bonus for you, and the bonus is calls. Calls is also a kind of expression. Let's talk about the simplest form of call, which is a function calls. We will talk briefly about it over here, and we will discuss the details later on. So what is a function call? So this is the simplest kind of the call that invokes a function. So a function call includes the name of the functions, a pair of parentheses, and a few arguments which are separated by commas. Now let me tell you this, that we have already been using function calls. Can you make a guess in the comments which function calls we have used so far? Python has fairly small number of built-in functions. So the most common function is the length function. If you want to see the length of any of the string, you can use this len. You can use this function len. Now this is the name of the function. Then we have to add a pair of brackets. Over here we can type our strings atgc tat. Then you have to close the bracket. So this will give you the length of the string, which is 13. If you want to print something, you can use the print function. Now this print function might not make much sense to you right now since we are working in Python shell. It is gonna be really helpful for debugging the code. We will talk about later when we will start writing Python files. If you want to take the input from the user, we have input function. You can type please enter DNA string. When I will hit enter, it will ask me to enter something. Please enter a DNA sequence. I can type ATGCTATAGCA. Now you know that I am getting an error because I forgot to enter the commas. Let's call it again and try it with some commas. ATGCTATAGC. Okay. Now there is another important thing that I would like to get familiar with this in Python, and this is the help function. Whenever you are unable to understand anything about Python, you can use this help function. This is telling you how to quit it and how to get the things. So if you want to see what is an int in Python, just type int over here and hit enter. It's gonna tell you that from which class it belongs to, what it does, how many functions are there, how many methods of int are there, and you can keep exploring things over here. If you want to quit, just type quit and hit enter. You can also get into the Python help by using help, and in the parentheses you can type int, and it will just open the same thing. You can also add a number or float over here, and it will also get you all the details about the floor. Alright, so let's talk about method calls. In Python, most of the functions are a part of specific implementation. These are known as methods. Calling a method is just like calling a function. The only difference is that the first arguments come before the name of the function. So we have this method count, takes the string as the first argument, so we will have to type the string on our own first, AT. Then we will have to enter a dot, the name of the function, count count, and in the braces you will have to enter the second argument. So what we want to count over here. We want to count ATs in this whole string, and we will put AT over here, and you can see that there are 10 ATs in here. So count is a method of the string. If you want to see what are all the methods that are available for strings, you can just type help and type str over here and scroll down. You can see that these are all the method. This is contain method, format method, this is the len method. Moreover, here we have our count method, decode method. If you want to read the details about all of these, you can use the details. This is a find method. It returns the lowest index in the string where substring is found. So the list goes on and on and on and on. This totally depends upon you, how much you are interested in understanding the things in Python. Keep on exploring, keep on digging down. So that's all up to you, how deeply you want to study all the things. However, I have covered all the basic things. If you go through this whole video, you are good to go. And now let's talk about our website. So I have created this website, bioinformaticsguy.com. You can open it just like that, and you can see that there are all the videos are mentioned over here. Now this website is still under development, and that is why whenever you will open a few posts, you will see something like this. Website is under development, written material will be added soon. Now the main point of making this website is that sometimes you are not in the mood of watching the whole video. You want to read something, you want to see the script. So I have made this post about the first video of my series Machine Learning in Bioinformatics, and you can see that I have written all the details about this video. I have explained everything in the text format. Moreover, I have included the code in this format. Let's go to the second post, and you can see that everything is written over here with the great detail. And then you will also be able to see some scripts over here. All the Python scripts that are going to be used in the videos, you can find them here. So here is the series video list. If you want to hop into a certain video, you can go from over here. So go ahead, take a look at this website, and I am open to all the suggestions about this. There is this contact page, you can talk to me. Type your name, type your email, type your message, and just hit send. I will get back to you each and every message over here. So that's pretty much it for today. If you have any comments, concerns, or questions about this video, you can always hit me up in the comments box. I would be happy to help you out. And if you want to see what I do other than programming, you can always check out my vlogging channel over here. Thank you very much for watching and all the support. I will see you around in the next video.